This is Anthony Precella. Today in college algebra we're going to be looking at absolute value equations. We'll begin the course by reviewing what the heck is absolute value. Well, absolute value is denoted with two vertical bars. That's not 11 I just wrote. The absolute value of, let's use some letter x, is the distance. See, distance is never negative, is it? Between 0 and the number x on the number line. That number x always makes me laugh. I think of my mother. She's 91 now. And if I said the number x, she'd be like, no, you mean letter x. It's not a number. Okay? But again, I guess she didn't have a lot of algebra in her education. So it's the distance. Distance can never be negative. If someone asks you, what's the distance between Corpus Christi and Houston, you can't say negative 220 miles. So if we had something like the absolute value of the number 3. Well, the distance between 0 and 3 on the number line, if you had to count those units, it would be 3. Now what if there were negative 3 inside there? What's the absolute value of negative 3? Don't say negative 3. Well, what is it? Yeah, still positive. The number on the right can never be negative. Okay? Number on the right can never be negative. I guess we could say formally the absolute value is always a non-negative number. Most people say positive, but well, there's one number whose absolute value isn't positive. What's the absolute value of 0?
0.
Yeah. And since the absolute value of 0 is 0, that's why you'll hear formally, and you'll see in books, absolute value is non-negative rather than absolute value is positive, because 0 is not positive. What I say is absolute value is never negative. That takes care of that. Okay? So this number on the right can never be a negative number. In math, algebra especially, you always do it one way, then you do it in reverse. When you first saw these absolute values in whatever course that was, however old you were, you first started off, okay, they give you the number on the inside, you had to figure out the number over here. Okay? Then, somewhere along algebra, once you were studying algebra, you would have had something like this. Solve this equation. The absolute value of x equals 5. You're now doing it in reverse, trying to figure out what numbers go inside the absolute value bar. Okay, so can y'all figure that out just by inspection? Can y'all tell me one number that could be inside there? 5. Suppose I said there's two of them, positive 5 and negative 5. So our answer here would be x equals plus or minus 5. In my math lab, you would type in the plus minus and then 5, or you could just write 5 comma negative 5 if the plus minus key wasn't showing on the for you to click on. Now, let's look at problem number 1. Again, I printed out this assignment. I'm just going to work through it. Problem number 1. Can y'all see that? It says absolute value of x equals 11. Well, I claim there's only two numbers that can be inside those absolute value bars. What are those two numbers? 11 and negative 11. So you can either type in plus minus 11 if the plus minus key is showing, or you might have to, if it isn't, you might have to type 11 comma negative 11. Okay? And I'm not sure if on the key, when you click on the little box, if it shows the plus minus or not for those. I should have looked beforehand. Now, what about number 2?
Would it just be 17?
Let's see. Let's look at these answer options. You have the solution set on number 1. The solution set is where you type in the numbers. Or B says the solution set is the empty set. That means there's no solution. Let's go back to what we did right out here. The number on the right, can it ever be negative? No. So looking back at number 2, absolute value of x equals negative 17. It doesn't matter what number you put inside there, positive 17 or negative 17. Once you actually take the absolute value, you should be getting a positive 17. What am I trying to hint at that we would choose here for this answer? No solution. So let's go ahead and make a note. If it's absolute value equals a negative number, then there's no solution or empty set, however you want to word it, or however it's worded here. Have y'all ever seen the symbol for empty set? It's a little circle with a slash through it. Okay. So if you have a negative number over there on the right, right, absolute value can never be negative. Now, third one, it's starting to get more involved. The absolute value of x equals 12. Let me go ahead and write that down. So larger. So let's see. I'm writing down the problem. Absolute value of x minus 8 equals 12. Trying to solve absolute value of x minus 8 equals 12. You can't even tell that those are blue and black when you look up there, but when you watch it on the screen, it'll be obvious. Blue, black. As it usually is. Okay, so how would we figure out this? Well, let's logic our way through it. I'm going to cover up that x minus 8, and you tell me what are the only two possible numbers that could be inside there. What are the only two numbers that have absolute value equal to positive 12? Negative 12 and 12. Okay? So, you take what's inside here, the x minus 8, set it equal to positive 12, and then set it equal to negative 12. The logic here is the only two numbers that can be inside those absolute value bars are 12 and negative 12. So I'm telling you how to solve an absolute value equation if there's something more than just x in the parentheses, in the absolute values. If there's just an x, there's only two things you do. If it's a positive number over here, you say plus minus. If there were a negative number, you say no solution, empty set, however they word the no solution. Okay? But if there's something other than just x inside there, what you're thinking is, okay, x minus 8 needs to either be positive 12 or negative 12. Let's go through and solve those two equations. Let's see. Would y'all add 8 to both sides? So 12 plus 8, would that be a 20? And what else? Over here, have y'all got the hang of my little arrow notation? That little arrow means add 8 to both sides. That arrow is the same thing as doing this. Plus 8 plus 8. So what number would we get? X equals -4? Okay. So 20 and -4 are our solutions here. Now you can sort of check this just to make sure you understand the logic. If you plugged a 20 in for x, what number would we get inside here?
12.
12. And the absolute value of 12 is 12. Now what if we put a -4 in for x? -4 minus 8 would be -12, and its absolute value is 12. Okay? So let's make a statement. To solve absolute value of something, it doesn't matter whatever's in there, anything, equals a positive number. Why am I saying positive? Well, remember, if there were a negative number over here, you'd say no solution. To solve absolute value of anything that was positive, you're going to solve these two equations. Take what's inside there, set it equal to positive of that number, and then set it equal to negative. Just like equals positive 12 equals negative 12. Okay. Any questions there? The next one's going to be the same type of logic, but a little bit more involved. Let me write it down. Oh wait, let me go ahead and make a note. The answers were 20 and -4. 20, let me get a 20, comma, -4. Oh. Now, problem number 4. Absolute value of 4x minus 7 equals 8. Trying to get rid of that little black area out here. Well, let me write it down. Absolute value of 4x minus 7 equals 8. We're just working through the assignment number, well, the next assignment. It's reviewing solving absolute value equations, and we're just discussing what absolute value was. We said the number over here shouldn't be negative because absolute value is a distance, and distance can never be negative. And we said, okay, like right here, the only number that could be inside here would be positive 5 or negative 5. If there's something more than just an x inside there, you say, okay, equal positive this number or negative this number. And now we're up to this one. Absolute value of 4x minus 7 equals positive 8. And that's too bad. Absolute value of 4x minus 7 equals 8. If y'all had to type in the next line, what would you do? And again, that's what we're going to be, well, hopefully you'll be through with all your algebra before all of that comes about. But how will you be doing? What would you write here as your next line?
4x minus 7 equals 8.
Uh-huh. And what else would I write?
Plus 7 equals
Okay, you want to go ahead and solve that, but there's two things you write.
Negative.
Yeah,
4x
equals.
minus 8. Negative
The logic is the only two numbers that can be inside those absolute value bars are positive 8 and negative 8. And so what number is going to make x be a positive 8? Excuse me. What number is going to make all of that be a positive 8? What number is going to make all of that equal negative 8? I think we're going to have a fraction on this one. The logic was easier to follow over here on this one where, okay, 20 minus 8 gives you 12. You can do it so easily in your head. Negative 4 minus 8 gives you negative 12. So here we're trying to figure out what one of those x's would give us a make all of this be positive 8. What x value would make it be negative 8. Now, you've gotten ahead of me. What do I do now to solve this for x?
Plus 7.
Okay, add 7. So we have 4x equals, is that going to be a 15? And then divide both sides by 4. So we have 15 over 4. 15 over 4. There's one of them. If I plug the 15 over 4 in, do you remember how with multiplication of fractions, there's that cross canceling? Can y'all imagine replacing this x with 15 over 4? The 4's would cross cancel, and we just have 15 minus 7. That would give us the positive 8. It's not quite so easy to do in your head, is it? What about over here? Well, I add 7 to both sides. Normally, instead of doing this plus 7, what do? I just do that. And so on the left, we have 4x. What do we have on the right? Negative 1. Then divide both sides by 4. So we're getting a negative 1/4. So 15 over 4 and negative 1 over 4. So 15 over 4, comma, negative 1 over 4. Okay. When you're doing this, you can then, by writing it out like this, just on your paper, when you're around a computer, punch it in real quickly. Okay? Any questions on this stuff here? How to solve an absolute value equation. Now, remember, I made the statement here, absolute value equals negative, no solution. I probably should have written it on that other page. No questions? Here's a really important statement. I'll put a red star out beside it. Always isolate the absolute value bars first. Those absolute value bars should be on one side by themselves. Look at problems 1, 2, 3, 4. Absolute value bars are by themselves. Once you get to number 5, and that's not a 14. Let me write it down. This is number 5. Oh, let's see. Absolute value of 4x minus 4 equals 20. absolute value of 4x minus 4 equals 20. What am I trying to say? There's only one correct first step. If you do anything other than this, it's wrong. What am I trying to say with the little red star statement? Move the 4 over. Do y'all agree with that? Those absolute value bars should be by themselves. You should have absolute value equals number. Okay? So if I move this 4 over by adding 4, I have absolute value of 4x equals, is that going to be a 24? The most basic form of the most basic problem solving strategy is if you know how to do one type of problem, and we know how to do it if it says absolute value equals number. You either go equal positive, equal negative, or if the number on the right were negative, you'd say just no solution, empty set, whatever. So we now have it in the form that we know how to handle it. What's the next thing I'm going to do? What are the only two numbers? If I cover up that 4x, what are the only two numbers that can be in there? Negative 24 and positive 24. So you take what's inside here. And since you said negative first, I'm going to go ahead and write equals negative. Then I'll write equals positive. Doesn't matter the order. So 4x has to either be negative 24 or it needs to be positive 24. Absolute value bars. You should always isolate those first. And divide by 4. This is going to be one that you can check pretty easily. Negative 24 divided by 4 is negative 6. What about over here? Divide by 4. Are we going to get a positive 6? Now what do I mean by checking it? If I plug the negative 6 in here, 4 times negative 6, that's giving me negative 24. And the absolute value of negative 24 is certainly 24. If I'd plug this blue 6 in here for x, that's giving me positive 24. Hopefully the logic, maybe there's some stuff when we're doing it, you can be like, I don't understand the logic of why this is working. But this hopefully isn't one of them. Okay? And hopefully this is one of those times where, oh yeah, I understand the logic. The only thing that can be inside here is 24 or negative 24. So x has to either be negative 6 or positive 6. Let me write those down. I'll put plus minus 6. If it's not showing the little plus minus key when you're typing in the answers, it might be faster just to type in 6 comma negative 6. Or you can click more and look for it. Let's see. Now there's 2 more to do. Problem 6 and 7. Let's see. I'll print out this one all by itself because I'm going to work it out right here. Absolute value of 2x minus 3 all over 7 equals 9. And this one just looks bad because there's a fraction there. But let me go ahead and write it bigger. If you can see it as it is, then great. If you're having a hard time seeing it. Absolute value of 2x minus 3 all over 7 equals a positive 9. Don't let the fact that there's a fraction there scare you too much. Logically, let's think. How are we going to set it up? If I cover up all of that stuff in the absolute value bars, What's the only two numbers that can be inside there? What are the only two numbers that have absolute value equal to 9? 9 and negative 9. So I take what's inside there, 2x minus 3 over 7. It has to equal either 9 or what's the other equation I'm about to write? 2x minus 3 over 7 equals what? Negative 9? Now before you panic too much, we solved some equations that had fractions the last time, and I'm going to write it, this is 9 over 1 and negative 9 over 1. And when I have a fraction equals a fraction, I cross multiply. If you just want to say, okay, I'm multiplying both sides by 7, you're going to get the same thing. Okay? If I do the little cross multiplying, I have 2x minus 3 equals, is that going to be a 63? Now that would be the same thing as if you just said, okay, multiply both sides by 7. Here they cancel out. Here you'd still get a 63. Oops. So how would I go about solving this? I would need to, add 3 to both sides. So we have 2x equals 66. And then divide by 2. So if we plug the 33 in for x, that's going to give us a positive 9 inside there. 2 times 33 is 63. 2 times 33 is 66. Minus 3 is 63. 63 divided by 7 is 9. Okay. Are we ready to do the other one? Are y'all caught up with me? Well, the equation's going to look just like this one, except it's going to say negative 63, isn't it? 2x minus 3 equals negative 63. Add the 9. Add the 3. So we have 2x equals, adding 3, would that be a negative 60? And then divide by 2. Is that going to be negative 30? Y'all follow my calculations? Let me check it to see if I messed up. 2 times negative 3. If I plug the a negative 30. I'll put negative 30 here. 2 times negative 30 is negative 60. Minus 3 is negative 63. Divided by 7, that would give me a negative 9 in there. The absolute value of negative 9 is sure a positive 9. Okay. Any questions? Well, we have one more of these to do. Oh, the answers that I'm going to type in here. 33, comma, negative 30. Ooh. That orange is hard to read, isn't it? Especially under there where it's so bright. The glitter's so bad. And here's our next one. Hey, you know what? Let me position it like this. So that maybe, okay. Oh, it's sort of hard to read that. Let me write it out. What is this problem? It's absolute value, just writing it bigger, of m plus 2, and then a plus 8. So that's not 1m plus 21 equals 15. I probably shouldn't be showing the red star statement. Am I insulting y'all's memory as to how I would start this? There's only one correct spot, a correct way to start this if you want to get both of the correct answers. If you find yourself on problem 7 and problem 5, if on your problem 5 you get one answer right and one wrong, and the same thing here on number 7, if you get one right answer and one wrong answer, then you're not isolating the absolute value bars first. So what should I do on this one first?
Plus 8.
Oh,
Or minus 8.
okay, that's minus 8. Subtract 8 from both sides. So we have absolute value of m plus 2 equals 7. Now, is this one any harder than the other ones?
Easier.
Yeah, well, it's probably a little easier than number 6, isn't it? Okay? So, here's the logic behind this. What are the only two numbers that can be inside here? What are the only two numbers that have absolute value equal to 7?
-7 and 7.
Okay, so what's inside here? It has to be either a -7 or a +7. And to solve for m, what would I do? I would subtract 2 on both sides. So I have m equals, is that a -9 here? And over here, what would we have? Subtracting 2, would that be a 5? So 5 and a -9. Any questions on that? This is solving absolute value equations. Remember, that's going to be popping up in our next discussion, but I don't need that in the video. So, any questions over any of these problems we did? The logic here, again, this is some of that stuff that the logic should be clear in your mind why this method works. Okay? As long as you don't have absolute value equals a negative number, if you have that, then it's that no solution. Okay? Otherwise, you take what's inside the absolute value and go equal positive, equal negative, but make sure that you have those absolute value bars isolated first. That's going to be very important. Okay? If you don't isolate those absolute values, you'll probably get one solution that's correct and one that isn't. Okay? So, if there's no questions, then we'll call this quits over absolute values. Well, thanks for watching, and I'll be talking to y'all later. Sayonara.